Alright, welcome to lesson 910. What we're going to do, start off is refresh what we did in the last one, which is using the inverse and the quadratics to solve for these. Here's the quadratic function right here, is this. So I'm going to set it equal to 0, and I'm going to start solving. So, first thing I'm going to do, add 36 to both sides. I set it equal to 0 first, and then I'm going to add 36 to both sides. So I get 2 times x minus 2 squared equals 36. Remember, I want just the square on this side, so I'm going to divide by 2 to get rid of that 2. And I get x minus 2 squared equals 18. And then now we're going to go, and I'll change colors here. We'll take the square root of both sides, plus or minus over here. So x minus 2 equals plus or minus the square root of 18. Remember, square root of 18, bust down, half of it is 18 is 9. So I'm going to get x minus 2 equals plus or minus, and it's going to be 9 times 2, remember. So that makes it 3 radical 2. Last step, x minus 2 equals 3 radical 2. And you also have x minus 2 equals negative 3 radical 2. Add 2 to both sides. 2 to both sides, here and in this problem here. And your answer comes out to be 2 plus, let's see, you got 2 plus 3 radical 2. And the second one here, when you add it, is 2 minus 3 radical 2. Those are your two answers. In part B now, it says find the zeros of the nearest tenth. Well, guess what? We need the calculator. So in the calculator, I want you to punch in 2 plus 3 times radical 2 and 2 minus and come back with the answers. So your two answers are, when I do 2 plus 3 radical 2, I get 6.2426 blah blah, but the nearest tenth will be 6.2. And when I do the other one, I get negative 2.24, so it's negative 2.2. Those are my two answers in the nearest tenth using the calculator, okay? So a little review, plus doing a calculator, which we did not do yesterday. All right, time to move on. All right, so today now we're going to review how to do this by factoring and also how to do this by completing the square. Okay, so to do it by factoring, I've got a trinomial right here. There is no GCF, so I'm going to go straight to the Xbox method. My A is a 1 and my C is a negative 16. So when I do A times C, I get negative 16. And my B is a negative 6. Now I need the pairs that basically multiply to 16 and are a negative 6. So that's going to be, if you use your calculator, that negative 8 and 2 gives me a negative 16 multiplied and adds to a negative 6. So I have x squared. I have a minus 8x. Remember, I'm going to get the pairs from the middle here. Plus 2x and a minus 16 equals 0. I am going to factor by grouping, so I will group them up like this. So I will get x is what I can pull out, so divide them both by an x is what they share. So x times x minus 8. And in this one, they share a 2, so plus 2, so divide them both by 2, which will also be an x minus 8 equals 0. So my two factors are x minus 8, the one they share, and the stuff out in front is the x plus 2 equals 0. And if we're solving, you remember, we tee it up. So tee it up. X minus 8 equals 0. So if I bring the 8 over, I get x equals positive 8 when I add 8 to both sides. Add 8 to both sides. And on this side, it will turn out to be the opposite, negative 2. So there's one, there's two answers. Now let's go to completing the square. So for completing the square, if you remember, first thing we do is move the c to the other side. So I'm going to add 16 to the other side. I've got x squared minus 6x, and there's nothing out in front of the x squared, so I can put plus a box equals 16 plus a box. Okay? So then I take half my b, which is negative 3. I like to write it down below, and I square it. So remember, it's b over 2, and you got to square it. So that is a positive 9. Since I have a 1 out in front of the x squared, I put a 9 on both sides. I add it to both sides. So this side here, because I already wrote the x minus 3, I've got my square there. Just put it with an x side parentheses. And the other side equals 25. And now what you're doing is you're taking it around, and we want to come up with the zeros. So we will do the method we just did. Square root both sides, plus or minus over here. So I get x minus 3 equals plus or minus 5. So one answer is x minus 3 equals 5, and the other one is x minus 3 equals a negative 5. Remember, plus or minus. We need that part right there. That's why we got 2. Add 3 to both sides. So one answer turns out to be 8. Add 3 to both sides. The other answer turns out to be a negative 2. And if you take a look at the two answers, you will notice, voila, they are the same. All right, on to the next thing. All right, so in exercise 3, they're going to show you why completing the square is important in its own right and why we're doing both. We're going to actually do completing the square with this, and then we're going to try it by factoring. So, completing the square method, move the 2 over right away first. That's your C. X squared plus 6x equals just 2. Take half the b here, so half of 6 is 3. Squared is 9, so I had 9 on this side and 9 on the right. You could have used the box part. I will factor this up. This whole thing becomes x plus 3 squared equals 11. And then you're off and running like we did before. You take the square root of both sides, square root plus or minus, so you get x plus 3 equals plus or minus square root of 11. So now you set it up, so you got x. You're going to bring a 3 over there, so we're going to put x plus 3 equals square root of 11. And x plus 3 equals square root of negative square root of 11. Subtract 3 from both sides. Cannot combine them, they're not like terms, so you get negative 3 plus the square root of 11 on that one. And when you move 3 over on the other one, you're going to get x equals negative 3 minus the square root of 11. And those are your two answers. Now, by factoring, we want to look at this. Okay, so by factoring, we want to look at this. What's my A and my C here? Because I can't plot any GCF, so it's 1 times 2, which is 2, and my B is 6. And here's the problem. You go to factors and you say, okay, what times 2 will give me 6 in this whole thing, and use your calculator. Well, first way, the only way to get 2 is 1 and 2. Is that ever going to add up to 6? No way, no how, no way. So this is not factorable. Bottom line is our factoring method wouldn't work. So we have GCF. We do have one other method we're going to learn in a couple days, but this is what we're at. So this is not even factorable as far as that goes. And you can tell that if you go back to your answers here, because guess what? Aren't these irrational? We're left with square roots of 11. You're used to the ones that come out nice numbers or nice fractions or something. So they're rational. This is definitely irrational with this. So sometimes you have no choice but completing the square. You will not be able to factor it. So let's move on to another example. All right, so now they're talking about we've got several tools in our toolbox to investigate all these types of quadratics. And we're going to take a look at this one in standard form, and we're going to get the vertex. So as soon as I hear that, probably I'm thinking completing the square. So in this case here, I bring the c over the other side, so I keep my 2x squared minus 4x equals positive 16 when I add 16 to both sides. But I've got a number out in front. So if you remember, I got to divide both these guys by that number out in front, and I put it out in front. So I've got a 2 times what will be an x squared minus 2x plus a box, and that equals 16 plus a box. Half of negative 2 is positive 2, or half of it's positive, it's negative 1. I can't even talk. 2 out in front with the x. And if I square negative 1, I get positive 1. But remember, I got to multiply it. Don't put the 1 on both sides. I got a 2 out in front. So 2 times 1 is a 2 that I put over here. So that will equal 18. And then if you want it in vertex form, just bring the 18 back over here. So it becomes a minus 18 here, and that becomes 0. Okay? So they said, hey, write the function in vertex form and state the turning point. Well, what is the turning point officially here? In this one, the opposite of negative 1, which is positive 1, and minus 18. Now in part B, they say use your answers from part A to find the zeros. So if I've got 2 times x minus 1 squared, and before I shifted the 18 back over was equal to 18, all I have to do is divide by 2 here first, get rid of that like we did in class the other day. You get x minus 1 squared equals 9. And then, of course, take the square root of both sides to get rid of that square, so plus or minus. So I get x minus 1 is equal to 3, plus or minus. And then I've got to set up my two equations. So I'm not going to show that here, but just add 1 to both sides. And you're going to end up getting what the heck is this? Your changes have not been saved. Do you want to save this project? Yes.
Mr. O, do you have a test booster for Tyler? I don't know where they are. I always got it. We're just waiting.
I don't know, Mr. Payne. We're ready for that or not. I had a test. It was a retest type thing, but I don't know if I printed it. I'll print it. Why would this thing all of a sudden out of nowhere say, hey, do you want to save this thing? That is bizarre. What do you normally call them that you're saving them?
That will be, just call it Unit 9, Lesson 5.
Okay. So I will get a 1 plus 3. So I get 1 plus 3, which is equal to 4. And that's the one answer. And the other one is, I'm going to bring the 1 over 1 minus 3, which is a negative 2. That's your other answer. That's what x is equal to. So those are your two zeros. Part C, determine the y-intercept. So that's pretty easy. If you put 0 in, this whole thing will 0 out, this will 0 out, and you'll get negative 16. So basically it's 0, negative 16 is your y-intercept on the y-axis. All right, and in part D, draw a rough sketch. So I'm going to make my x-axis here worth 1 point each, and each my hash mark on my y-axis right here is worth 5. So what pieces did we learn? Well, if you remember back here, we have a vertex of 1, negative 18. So over 1, down 18 should be a point somewhere down here. Then we learned that I've got two zeros, one at negative 2 right here, and one at 4, those two. So negative 2 I'd put a point, and at 4 I would put a point. And we also just learned that the y-intercept was 0, negative 16, which would be right here. So those are the points I have. If I draw a sketch here, I got plenty enough stuff to come down, dip up, come on back up, and that would be the sketch of my thing. Okay? All right, time to move on. All right, so the last question we're going to go to, it says you got a quadratic function here, leading coefficients equal to 1. Based on this, write an equation of the quadratic in vertex form. So I need my vertex, which this is the key part here. So my vertex is negative 1, comma, down 4. So if you remember your vertex form, what do we have to do here? I need my axis of symmetry. So my vertex I know is going to be x, and then it's the opposite of this. So instead of minus 1, it's going to be plus 1 being squared. And then my y part here is a minus 4 equals 0. So that's completing the square, basically writing in vertex form. Just pull it out from there. Now write an equation of the quadratic in factored form. Well, the factored form comes from these two zeros, right? 1 at 1 and 1 at negative 1. So you need the opposites on there too. So you've got x, and it's going to be, what is it, a minus 3. So it's x plus 3. You want the opposite. Times the other one. Instead of x plus 1, it's x minus 1 equals 0. Because if I actually teed it up here, you get the opposite answers, negative 3 and positive 1. So that's what it will look like, equation in factored form. How do you establish the equivalent fractions? Well, they're just asking you how, but the bottom line is the two things are the same, so you could set them equally to and solve. Or, if I take the first part right here, and I actually solve for the zeros, meaning bring the 4 to the other side, take the square root of both sides and all that, should come up with the exact same two answers, okay? That's how you would do it. They didn't say to do it, but that's how you would do it. All right, hopefully that's good. We'll see you in class tomorrow.